Hello friends, I welcome you in lecture number 5 on relations. In this lecture, we are going to discuss about transitive relation, which is also another property of relations. So what is transitive relation? Suppose we are given some relation R on a set A, then this relation R is called transitive if whenever this type of pairs are present in R, that is AB belongs to R and BC belongs to R, then this must implies that AC is also in R. We can see the characteristic here. The second component of this order pair and first component of this order pair are same. So if this type of pairs are present in our relation, then if we consider these two, here first component and here second component, then resulting order pair must be in our relation. So whenever this happens, that is AB belongs to R and BC belongs to R, then we must have AC belongs to R. In other words, AB belongs to R, that means A is related to B, and BC belongs to R means B is related to C. So whenever A is related to B and B is related to C implies A is related to C, then we can say that relation R is transitive. So this is the definition. A relation R on a set A is called transitive if whenever AB belongs to R, that is A is related to B, and BC belongs to R, that is B related to C, then AC belongs to R, that is A is related to C for all ABC belongs to A. So whenever we want to check whether our relation is transitive or not, then we have to check for existence of this type of pairs in our relation. If this type of pairs are present, then we have to check that this is also present in our relation. For example, suppose we have 2 3 in our relation and say 3 7 is also present in our relation, and if our relation is transitive, then we must have 2 7 present in our relation. This means 2 is related to 3 and this means 3 is related to 7, therefore 2 is related to 7 if our relation is transitive. And if this is not present in our relation, then our relation is not transitive. So we understand with the help of this example. We have taken some relations on this set having 4 elements 1 2 3 4, and we have to check whether they are transitive or not. So this first relation is denoted by R1 and we have to check whether this is transitive or not. So again we repeat that we will check for this type of ordered pairs. AB belongs to R and BC belongs to R, and we have to check if this is satisfied, then we must have AC belongs to R. So we will search one by one, or we will check one by one, and if it is obvious that for certain pairs this condition is not satisfied, then we can write that particular two pairs for which this condition is not satisfied. For example, if we start with this one, then here second component and here first component are same. So 1 1 belongs to R1, 1 2 belongs to R1, therefore 1 2 must be present in R1, here 1 and here 2. Okay, we can understand in this way. 1 1 is present in R1 and 1 2 is present in R1. These two are same, therefore we must have 1 2 belongs to R1, that is present here. Similarly, we can check for another pair whose first component is 1. So there is no other pair whose first component is 1. So now we can come here. Now we can check for those pairs whose first component is 2. Here second component is 2. So these two, this is one possible pair. then this will also be there. So for this we can see 1 2 belongs to R1 and 2 1 belongs to R1. So if relation is transitive, then we must have 1 1 belongs to R1. So 1 1 is present here, so that is also satisfied. Now we can check for these two pairs. So for that we can see 1 2 belongs to R1 and 2 2 belongs to R1. We are considering these two pairs 1 2 and 2 2. So this must imply that 1 2 belongs to R1. So that is also satisfied. 1 2 belongs to R1. Now we come here, 2 1 belongs to R1, and I have to search for another pair whose first component is 1. So that pair is this one. First component is 1. 1 1 belongs to R1. So now we must have 2 1 belongs to R1. So that is present here. 2 1 is in R1. So in this way we have to check for each and every pair. Now we can come here for 2 2. So here second component is 2. So this is the pair whose first component is 2. So we can check for that also. 2 2 belongs to R1. First component, second component is 2. Here first component is 2. So we can consider these two pairs. 2 2 belongs to R1 and 2 1 belongs to R1. So this must implies 2 1 belongs to R1. So that is also satisfied here. 2 1 belongs to R1. So now we come here for 3 4. So 3 4 is present in R1, and this is the pair whose first component is also 4. So we consider this one. 3 4 and 4 1 belongs to R1. So if relation is transitive, we must have 3 1 belongs to R1. So now we check whether 3 1 is in R1 or not. So we can see 3 1 is not in R1. So this relation is not transitive. If relation is transitive, then whenever AB belongs to R and BC belongs to R, we must have AC belongs to R. So we have to check for all possibilities of this type. So if relation is not transitive, then we have to find out at least one pair for which this condition is not satisfied. So here our search finishes. We have obtained that 3 4 is present in R1 and 4 1 is also present in R1, but 3 1 is not present in R1. Here 3 4 belongs to R1 and 4 1 belongs to R1, but 3 1 is not present in R1. Therefore R1 is not transitive. So this is the way how we can check whether our relation is transitive or not. So if you want to prove that your relation is not transitive, then you have to find out this type of pairs for which this condition is not satisfied. Here we can say that 3 is related to 4 and 4 is related to 1, but 3 is not related to 1. Therefore R1 is not transitive. So this is just for understanding. For examination you have to write only this part, that this for these two pairs this condition is not satisfied, therefore R1 is not transitive. And if at the very first moment you can find out this combination, then you can directly write down that R1 is not transitive because this is not satisfied for these two pairs. Next relation is R2. here we are having only 3 pairs. We can start with 1 1 and we have to search for another pair whose first component is 1. So this will work here. 1 1 belongs to R2 and 1 2 belongs to R2. So I have to check for 1 2. So this implies 1 2 is also present in R2. Now there is no other pair whose first component is 1. So now we come here. We can see that 1 2 belongs to R2 and 2 1 belongs to R2. So we must have 1 1 belongs to R2. So that is also satisfied. Now we come here for 2 1. 2 1 belongs to R2 and we will write that pair whose first component is 1. So you can consider this also. 2 1 belongs to R2 and 1 2 belongs to R2. So we must have 2 2 belongs to R2, but we can see 2 2 is not present in R2. Here 2 comma 1 is present in R2, 1 comma 2 is present in R2, but 2 comma 2 is not present in R2. In other words, 2 is related to 1 and 1 is related to 2, but 2 is not related to 2. Therefore, R2 is not transitive. Next relation is R3. Here we can see 1 1 and 1 2. Now we can check directly. We can see these two are same. So we must have 1 2 belongs to R3. So it is present. Now we consider these two pairs. 1 1 belongs to R3 and 1 4 belongs to R3. So we must have 1 4 belongs to R3. Okay, we can check in this way. Here 1, here 1. So 1 comma 4 must be there. So we can see 1 comma 4 is there. Now there is no other pair whose first component is 1. So we now come for second pair. Now we will search for those pairs whose first component is 2. So here this is the pair. So 1 2 belongs to R3, 2 1 belongs to R3. So we must have 1 1 belongs to R3. That is fine. Now this is another pair whose first component is 2. So 1 2 belongs to R3, 2 2 belongs to R3. So we must have 1 comma 2 belongs to R3. That is also satisfied. And there is no other pair whose first component is 2. So now we come for this pair. 1 4 belongs to R3 and we search for ordered pair whose first component is 4. So 1 4 belongs to R3, 4 1 belongs to R3 implies 1 1 belongs to R3. So that is also fine. Now here also there is 4. So 1 4 belongs to R3, 4 4 belongs to R3. So we must have 1 4 belongs to R3. That is also satisfied. Now we come for this. Here I should write 2 1 belongs to R3 and I have to write that pair whose first component is 1. So that is all these 3 pairs. 1 1 belongs to R3. So this must implies 2 1 belongs to R3. So that is fine. 2 1 is in R3. Now we search for another combination. 2 1 belongs to R3 and again 1 2 belongs to R3. So this must implies 2 comma 2 belongs to R3. So that is present here. Another combination 2 1 belongs to R3 and 1 4 belongs to R3. 2 1 belongs to R3 and 1 4 belongs to R3. So we must have 2 4 belongs to R3 and we can see 2 4 is not present here. So we have obtained another combination for which condition of transitive relation is not satisfied. 2 1 is present in R3 1 4 is present in R3, but 2 4 is not present in R3. Therefore, R3 is not transitive. So we don't have to write all these things. We will just mention that 2 is related to 1 and 1 is related to 4, but 2 is not related to 4. Therefore, R3 is not transitive relation. So in this way we can decide that whether our relation is transitive or not. Let's check for R4. So 2 1 belongs to R4 and there is no other pair whose first component is 1. So now we come for here. 3 1 belongs to R4. There is no pair whose first component is 1. 3 2 belongs to R4. There is no other pair whose first component is 2. 4 1 belongs to, here I have to check for these two, that 3 2 belongs to R4 and 2 1 belongs to R4. So we must have 3 1 belongs to R4 and that is present here. So whenever we check for every pair, we have to keep in mind that we are not missing any pair. Here second component is 1, so I have to check that there is no pair whose first component is 1. Then same thing for here, second component is 1, there is no pair whose first component is 1. Second component is 2, so there is no pair here whose first component is 2, but here also we have to check. So here we obtain one pair whose first component is 2 and this must imply 3 1 belongs to R4, that is fine. Now 4 1 here, so there is no pair whose first component is 1. Then 4 2 is present in R4 and we have a pair whose first component is also 2. So 4 2 belongs to R4 and 2 1 belongs to R4 and this must implies 4 1 belongs to R4. So that is also satisfied and there is no other pair whose first component is 2. Now we come here for this 4 3 is present in R4 and I have to search for those pairs whose first component are 3. So these two pairs are having their first components as 3. So I have to check for these two. 3 1 belongs to R4. This must implies 4 1 belongs to R4 and that is present here. Now 4 3 belongs to R4 and now I have to write for this 3 2 belongs to R4. So this implies 4 2 belongs to R4. So that is present here. So we have checked for all the possibilities and we find that condition for transitive relation is satisfied. So this means our relation R4 is transitive and we should check that we should not miss any type of combination. If we are missing some at least one combination also, and if that condition is not satisfied for that combination, then we may have wrong decision that our relation is transitive. So our relation is transitive if whenever AB belongs to R and BC belongs to R implies AC belongs to R, and we have to check for all type of possibilities for all the ordered pairs in our relation. So in this way we can decide whether our relation is transitive or not. Here we have taken our relations on finite set and we have not taken relations on infinite set. So that also we will discuss in future whenever we proceed in our this series of these relations. So this is all about this session. Thanks for